Alright, so we're going to look at this exponential function f of x equals 3 to the x minus 2. So my suggestion when you're working with exponential graphs is to always check what about when x is 0 and what about when x is 1. Those are 2 points that are going to be very helpful in giving you the basic shape of your graph. So if I plug in x is 0, that is f of 0 equals 3 to the 0 power minus 2. But we know that 3 to the 0 power is 1. So that's 1 minus 2. So f of 0 is negative 1. So I'm going to come over here and start my graph. And I'm going to go through the point 0, negative 1. Alright, now I'm going to plug in f of 1. So when x is 1, that is 3 to the first power minus 2. And 3 to the first power is 3. And 3 take away 2 is 1. So I go through the point 1, 1. Alright, then what I'm going to do is I'm going to back up and I'm going to call g of x just 3 to the x power. I know that this function goes through the point 0, 1, and it goes through the point 1, 3, and I know it's going to have an asymptote at y equals 0. So I know that this function goes like this. So my function has just done a vertical shift down 2 units. So if this is my g of x, my f of x is going to go like this. Alright, and what we want to be able to do today is we want to be able to analyze exponential graphs. And so that means we want to be able to say all the characteristics just like we've done with other graphs throughout the year. So I'm going to start with domain. Domain is all of our x values. Do you see any domain restriction? No, so our domain is negative infinity to infinity. You could also write all real numbers. No restriction to our domain. Alright, what about our range? Range is all the y numbers. Do we have an asymptote here? Go ahead and draw that in. Our asymptote shifted down 2 units. Usually our asymptote is on the y-axis, so our asymptote shifted down to y equals negative 2. So the lowest point on my graph is real close to negative 2, but it's not going to equal negative 2, so I'm going to put a parentheses, negative 2, all the way up to infinity. Parentheses, because I'm not going to touch the negative 2. If I did, I'd put a bracket, but that asymptote tells me I'm not going to touch the negative 2. So domain, range, those are important things. Asymptotes, well, we just wrote it down, y equals negative 2. It's a horizontal asymptote. Intercepts are important to note. So where's our x-intercept? So our x-intercept is right here. Somewhere between 0 and 1. I'd actually let the calculator tell me that x-intercept. Do you guys know how to do that? Everybody grab a calculator. I'm going to go to y equals, and I'm going to type in my function, 3 to the x power minus 2. Alright, and I would like the calculator to tell me my x-intercept. So you see on top of the word trace it says calc. So I'm going to do second calc. And I want to know my 0, right? An x-intercept is a 0. So go down to number 2. And now I have to know what an x-intercept looks like. So I have to be on the left of the x-intercept and hit enter. Then I have to use my arrow to get over to the other side of the x-intercept and hit enter. And then I don't want to guess. And so there's my x-intercept, 0.63092988, and that might keep going, and y is 0. So I'm just going to put x-intercept is approximately 0.63. Sometimes your exponential functions won't even have an x-intercept. This one has an x-intercept because it did a vertical shift down. Other times, if you don't have an x-intercept, you'll just write none. All right, what about our y-intercept? Your y-intercept is wherever x is 0. So our y-intercept is at 0, negative 1. All right, so I have domain, range, asymptotes, x-intercepts, y-intercepts. Is our function increasing or decreasing? Increasing. Right? So we're looking from left to right. As x gets larger, f of x is getting larger. It's increasing. And it's increasing on the entire domain, right? So I would say it's increasing from negative infinity to positive infinity. The whole function is increasing. Doesn't have any spots where it's decreasing. All right, then the last thing we want to talk about is end behavior. And some of you are still having a little bit of trouble with writing end behavior in limit notation. So maybe this will help with that idea. So, for my end behavior, first I'm going to do the right end. So the right end means as x goes this way towards infinity. So I'm going to write that down. X goes toward infinity. The limit, so I put LIM right on top of that. That's where it belongs. The limit of my function, f of x, is equal to. So as x gets bigger and bigger, my function goes towards infinity. Okay, so now I have to do the other end. So the other end is as x approaches negative infinity. So x approaches negative infinity, and then the limit, LIM, gets written on top of that. And so the limit of f of x equals, so as I go towards negative infinity, my outputs get closer and closer to this asymptote, so they get closer and closer to negative 2. So negative 2 is equal to the limit of f of x. So that's everything we would write down to analyze the graph. Now, what if I was asked to give the transformation from g of x to f of x? If you were going to describe the transformation, what would you say? Okay. what type of a transformation are you doing if you're going to shift, right? So vertical shift down 2. Or you could say translated, vertically translated down 2. But you want to have a verb in there.